So welcome back guys. Today we have another problem, that is minimum steps to destination, and the problem states that you have to start from zero and you have to reach the destination 2. How you can go to the destination 2? Either you can add plus 1, then you can add plus 2, and so on. Either you can add plus something, and either you can add minus something. Like in the first step, you can have either some positive values and the negative values. And the series was like 1, 2, 3, 4, dot, dot, n. And the another series that is for minus 1, minus 2, minus 3, minus 4. Basically for negative series. And for every step, you have two options. Either you can either you can have this one or this one. So in the question, they asked that to make the destination 2 from 0. So what can be the options? For the first option, you can take this one, and the second option, you can take this one, and sum will be here minus 1. And for the third option, you can choose this, that will be 2, and that will be our answer. So for every step, we can either have positive value and the negative value, but we have to move forward. Like if you choose this 2, and then we cannot go back to this one again. So we have to go forward always, and that is the question that we have to do, and we have to carefully choose this value to make the steps minimized. Okay, so let us go to the approach. Basically, you can use dynamic programming or recursion, and think of the brute force approach. Basically, you have to check all the combinations, right? And that part, that is the minimum that you can choose from the recursion tree, right? But there is an issue. Let us discuss about the issue. So let us start from zero. We have two options, right? One is 1, another is minus 1. If we take 1, then the answer will be 1, and here minus 1, and for here, suppose this is the 1, this is for 2. Now we are taking for last 2, then the answer will be 3, and we are taking minus 2 here, then the answer will be minus 1. And for here, that is 1, and here that is minus 3, right? And still we are not getting our answer, right? The answer is 2, our goal, no. So for that, we have to iterate again, and here the answer will be 6 because we are adding 3 here. Now we are subtracting 3, so it is 0. Now this is 2, and now you can see that when we are adding 3, then we can have the answer 2. Means the path can be 1, then minus 2, then 3. So that can be one answer. And the recursion tree will be moving like this. Now you can think like, okay, it is easy. Then we will memorize this tree and get the answer, right? Then think about it. What will be the best case, right? You have to stop, right? So there is no best case as such. Why? Because we don't know how many times we have to go to for the negative part and the positive part. You cannot write like this. Okay, our target is 2, so we will not consider this 6 because this 6 is greater than 2. But who knows? If you are taking the negative part and you are getting the answer, and maybe that answer can be minimum, it can happen. So you cannot take negative or you cannot use any base case like that. So recursion will not work, and this approach will not work basically. Okay, so we know for reaching to destination, we have several things, right? Like we can either use positive numbers or we can either use negative numbers. Basically, to reach the destination, we can either take 1, 2, 3, dot, dot, dot from the in and the negative ones. -1, -2, -3, dot, dot, n. And if we sum up this, we can have the destination, right? Now think about this. We can make an equation like how we know for 1 plus 2 plus 3 plus dot dot n. What is the summation? That is the summation of AP series. Basically, n plus 1, sorry, by 2, right? So we know this thing. So how can we generate our equation from this, right? So what can we do? Suppose we are taking all the positive number to make our answer. Then this thing will be equal to our destination, right? Then we can count the number of n and we will have our answer. But when we are taking all the both positive and negative values, then what can be? Then basically we have to divide all the positive and the negative values separately into two sets. Let us write that. Let us think for x, we will consider all the positive values, and for y, we will consider all negative values. So if we remove the negative sign from the y and uh, x plus y, that will be is equal to that thing, that n plus that the AP series sum, n into n plus 1 by 2. And if we use the negative sign also, then we can get like this, x minus y, and that will be our destination. Means for x plus y, it is n plus 1 by 2, and for x minus y, it is the destination. I'm repeating myself again. Basically, if we consider both positive and negative values as the positive values, then we can sum up this and we can have the sum of AP series. Like you can think, right? For 1, 2, 3, 4, and for -1, -2, -3, and -4. Suppose you are taking this one, this -2, this -3, and this 4 to make your answer. So if we make this -2 and -3 positive, then sum up this and you can get this number. So that is one of the equation. And another equation is if we keep the signs as it is, then we can have D, the target. Obviously, you can make using these values to have the target, right? So it will be also satisfied. So both the equations are true. Now we have to add this equation to get the value of x. Now look, if we add those equations, the answer will be 2x. The y will be removed, and we can have d. Sorry, we can have n plus 1 by 2 minus d. Okay, so now we can take this d into this side. So the equation will be, sorry, not minus, plus d, sorry, because we are adding this. So d, and the remainder will be the result will be n plus 1 by 2. So if we carefully observe that for the value of x and it is multiplied by 2, then this part should be always even, right? Because there is 2 into x and that is equal to this value, then this value will be equal to any even number. This is right. So we can make one condition like this. If we make our d here, then we can check like this. If 2x minus d mod 2, if that is even, then this equation is also true. Okay, so we have to somehow manage to get this equation be satisfied. How? That will be considered in our coding part, and we have to think for another condition, that will be whenever we cannot have the maximum the current sum to the destination, we will add the value into the let us say I. Means I am telling that suppose the initial value is 0, obviously, as they mentioned in the question, and the target is suppose 10. So we will add 1, then 2, then 3, because we know to reach 10 we can only consider positive values until and unless we reach 10. If we cross the 10, then we can use this condition, right? So for this, there will be another condition, that is I less than d, and both will be or. Okay, so we have these two equations that needs to be satisfied, and fully you have understood the intuition. It is kind of mathematics, not proper DP problem. But yeah, uh, this is how you can approach this question. Let us go back to the coding ground. Try to write our code, and let us take a variable that is sum, that will be 0 initially, and the count, that will be also 0. Let us make a while loop, and what will be the conditions? One condition is this. This is basically sum. Okay. So the sum is less than d. We will increment. We will add the positive values. Sum is less than d. And the another condition, that is this. What is this? What that means? Basically, we have to make that 2 into x minus t even. So we have to write like this. So it is basically the sum, and my 2 into x is the sum, and this is the target. So sum minus d, that should be even. Then we will stop. So we can write like this. If it is not even, means the mod 2 not equal to 0, then we have to continue. We cannot stop here. So the sum will be count and count plus plus. So okay. So let us return the count, and that should work. Let us try to submit the code. Okay, so they are matching. For another test case, suppose 14. Great. So it is working. Let us try to submit the code. Yeah, it is working. So what will be the time complexity? Obviously in, because we are using while loop and we are traversing until the sum is not equal to d and this condition. And for the space complexity, we are not taking any extra space, so that is order of 1. And yeah, so that is our approach. Hopefully you have understood the intuition. It is not a simple question. You have to use mathematics here. So thank you. Signing off.